Hello, let's continue our Sudoku adventure with RuStLe by Riffclown. And the RSL are capitalized because it is Region Sumline Theme Week. We are continuing our August theme week with this puzzle. So let's go over the rules. So we have almost normal 6x6 Sudoku rules. They're called irregular 6x6 Sudoku rules. And so irregular kind of implies that maybe it's not so normal, but it should still feel familiar. So irregular just means instead of boxes, we have regions of whatever the setter feels like. There's still 6 of them, and they still have 1 to 6 once each. So let's go over that carefully. In each row, in each column, we are still in the same way that you're used to, placing the digits 1 to 6, exactly once each. If you want terminology, we are still a Latin square. And then in addition to that, normally we would have these 2x3 regions, 2x3 boxes, we would call them. Instead, we call these regions, which is why the name of the constraint is region sumline instead of box sumline, because they work with regions in general, and a box is a region, but a region is not a box necessarily. Kind of like how a square is a rectangle, but a rectangle is not necessarily a square. And so in this case, we have these irregular regions. They're bold outline, just like a box would be. And we're placing the digits 1 to 6 exactly once each within each of these regions. Some people call this a jigsaw. That's an older term, but it checks out. All right. And so then we also have these blue lines in the grid. These are region sum lines. We've been doing this all week, but I will explain them in case this is your first video of the week. And so the way these work is we are segmenting the lines whenever they pass a region border. So for example, this line here, these 3 are one segment, and then this purple one on its own is a segment of length 1. And each segment on the same line has the same sum. So between 2 different lines, they might have the same sum, they might not. Segments between 2 different lines. But within the same line, segments have exactly the same sum as each other. So whatever these 3 add up to, that's going to be put there. Another example, how about this one here? Let's use blue, purple, green. So whatever these 2 green cells add up to, that's one segment, right? This is a segment, this is a segment. You can see that we segment when we cross region borders, including if you cross them diagonally. And so the blue, the purple, and the green sum to the same amount as each other. All right, and that's it. Those are the rules. There is a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Sorry, I'm going to move something on my desk. It's jiggling around. Okay, so I want to start here because these 3 cells must be different from each other, right? In fact, region sum lines within a sum, you can never repeat digits because that's kind of the point. Within each region, we're having a different sum. And so these 3 digits, they can't repeat. And so what's the minimum we could put in here? We're even ignoring this given here. Is 1, 2, 3. The very minimum I can put in here is 1, 2, 3, and that adds to 6. And then that needs to be the same as whatever digit we place here because it's a 1 cell segment. And so the biggest digit I can put in there is a 6 because we're placing 1 through 6. Biggest digit's a 6. And so if the biggest it can be a 6 and the smallest it can be a 6, then it must be 6. And so this is what it is. It's 1 plus 2 plus 3 equals 6 is the only way we're doing this. And then this 1 tells us that's not a 1. That does put 4, 5, 6 here. I'm going to fill that out, remove this 6 here. And then, let's see, what else do I want to do? So this is 4, 5, or 6. Okay, this does the same thing here, though, because these 3 digits are in a region. Minimum is 1, 2, 3. Maximum here is 6. And so we get the same deal. And so now this is a 4, 5 pair. And this is a 1, 2, 3. Now this region sum line just says put the same digit in both of these cells. So that's what we're going to do. It's also 1, 2, 3. This is a 1, 2, 3, adding to 6. Wow, we're just being given all sorts of these. This is a 4, 5 pair then for the column. All right, we got to pay attention to the irregular probably at this point. Let's think about this. So this could be a 6. I'm starting to think it probably is. Okay, at the very least, we can say in this region, 6 is in one of these 2 cells. And then in this region needs a 6 as well. It's in one of these 2. Okay, so 6s are like this. In fact, we can put 4, 5, 6 in here. Get rid of that 6 there. Oh, that's a 4, 5 pair. So this is 1, 2, 3. This is also 1, 2, 3 just for the row. We had the 4, 5, 6 already. And so now this is the other 4, 5 in this box. All right, I feel like we're going to have a very satisfying disambiguation right at the end. I think this line's going to do it for us, but let's see. Is there anything else I can mark before we do that? I don't think so. So these two cells here, do we want to minimize? Because I feel like, let's see. Let's minimize these two cells because there's the 1 in this region. So these can't use 1. Now, can they be 2, 3? And the answer is no because of the row. Look at the row now. We've got 4 cells that want to be from 1, 2, 3. That doesn't work. Basically, one of these has to be a 4, 5, 6 because we need to place 2 more 4, 5, 6s over here. Only one of them can be from 2, 3. So the minimum I can put in here is a 2, 4 pair. That's 6. And the maximum I can put here is 6. So this is a 6 and this is a 2, 4 pair. Right, I can't get any smaller than 2, 4. I can't use a 1, and if I try to do 2, 3, which is the only way to get smaller while not using a 1, we break the row. So we get these 6s. And now these add to 6. Neither of them can be 1 either, because this one sees both of them. So this is also 2, 4 adding to 6. All right, 2, 4 pair does give us the 3 and the 5. That's 4, that's 5, that's 4, that's 5 and 4. Nice, that's 2 and 4, and that's 2 and 4. That's a 5. Very satisfying. This is 1, 2, and 3. That's 4. Okay, this isn't a 3, meaning this isn't a 3, and this isn't a 2, meaning this isn't a 2, so they both have to be 1. All right, these aren't 1s. Okay, we get the 2 and the 1 here. All right, we get our 5, 3, and 1. We get the 2, 3, and 2. I think we're finishing. We doot in the corner. This is a 3, and then here we need 3 and 5. So that's a 3, that's a 5, and we're done. Very nice. I like that, Riffclown. Basically, how many ways can we restrict a region sum line to have a sum of 6? So remember when I said that 2 different line segments in different lines can have different sums? Well, in this case, they all have the same sum. So that's pretty fun. All right. Well, hope you enjoyed this. I did. If you did, then why don't leave a like, subscribe, and a kind comment below.